Hello, today we're going to talk about electron domains. So I've already put together one example. I haven't put together any other examples just yet. I just wanted to make sure I could tie a balloon, and it went okay. We'll see how the rest go. Anyway, so this is going to be going over electron domains. There are 5 of them. A little bit of background information. All atoms are connected to a central fixed atom. And then Vesper states that the electron domains repel each other. So all the electrons are going to try to be as far apart as possible. So again, there's 5 domains. We're going to start with the first one. This one has 2 domains, okay? So it kind of looks at where the electrons are, where the bonds are. So in this is the linear shape. 2 domains represented by the balloons. And then if you think of like the center part, that's where the central atom is, right? So central atom, 2 bonds, and then on the edges there are 2 atoms. So in total there are 3 atoms. It is a linear geometry and no lone pairs. So then I'm going to try to make the next one. There are 3 domains in this next one. Okay, so it's going to be trigonal planar. So it's all going to be in the same plane. And go easy on me, because tying balloons is not my forte. So again, this one is trigonal planar. There are 4 atoms involved. You can have a lone pair with it. An example is O3, 3 oxygen atoms. I don't know if I gave the example for the 2 domains, but that was going to be CO2. So I'm going to try to tie this on here. We'll see how it goes. I'm really bad at this. This might turn into like a 15-minute video simply because of the tying. Maybe we can kind of leave it at that. Okay, so all on the same plane for the most part. And that's our 3 domains, our 3 electron groups between the atoms. If you imagine it, would be on the end of each balloon and in the middle. So the next one, 4 domains, that's going to be a tetrahedron shape. Okay, so essentially we're just going to add 1 balloon on the top here, and it's 5 atoms total. You can have 2 lone pairs. An example is NH3. Okay. There goes that one. Let me see if I can tie these together. I'm not good at this. Eventually they will stretch out and hopefully just tie together. Come on. Come on. Nope. I blame it on working today. I worked 12 hours today, so I just don't have the strength in my hands anymore, apparently. Let's see if I can make this work. Hold on. We're going to try a new strategy here. Got it. Okay. Perfect. So as you can see, tetrahedron, the 3 on the bottom, the 1 on the top. Okay, 5 atoms, could have 2 lone pairs. Example is NH3. Okay, so next we're gonna go to the 5 domains. So that's gonna be trigonal bipyramidal, or trigonal bipyramid. So 3 are gonna be in the trigonal plane and 2 are gonna be pointing in the opposite direction. So I'm just gonna add 1 on the bottom here. 6 atoms total. Example is phosphate PCl5, we'll say that. 3 could have 3 lone pairs. Okay, so let me get another one going. See, that part's easy. I don't even know how I'm gonna get this to attach. But if I hold it like this, that's kind of the gist. So you got the 3 in the plane, the trigonal plane, and then you got the 2 on the top and the bottom in a linear fashion. Okay, so we'll leave that there for now. Lastly, 6 domains. This is gonna be an octahedron shape / square bipyramid. 7 atoms. An example is xenon, and then fluorine, 4 fluorines, XeF4, and you can have 4 lone pairs. Okay, so essentially, I'm just going to add 1 more right here, and then we'll have the top and the bottom balloons. Alrighty, so let me see what I can do to make this work. Making the balloons smaller, see if that gives me a little bit more room to work with. And it does. That was a lot more easy. Okay. That was a lot easier than I thought it was going to work out as, but as you can see, 1, 2, 3, 4 in a plane, top and bottom. And again, that's the octahedron or the square bipyramid. So 7 atoms. These are all around this central atom that's still in the middle. And I can have 4 lone pairs. And that is all. Those are our electron domains.